So what we looked at above was an angle formed by a tangent line and a chord where our vertex is on the circle. Now we're looking at angles inside the circle. And these can be formed a number of ways. So theorem 1012 tells us that angles inside the circle theorem, that if two chords intersect inside a circle, then the measure of each angle is going to be half the sum of the measures of the arcs intercepted by the angle and its vertical angle. What this means is as follows. If we have a circle, a better drawn circle than that, we have a circle and we have two chords. These do not need to be diameters, they just need to be chords. So we have chord AB and chord DE, which intersect at point C. This forms angles 1 and 2, which intercept arcs AD and arcs EB. Then what we see is that the measure of angle 1 equals 1/2 of the measure of arc AD plus the measure of arc EB, and that the measure of angle 2 equals the same thing. Measure of arc AD plus the measure of arc EB. So our two intercepted arcs, we add them together and then divide by 2 to find the measures of our angles. That's for angles that are inside the circle. Angles outside the circle are a little bit different. This gives us theorem 10.13. This is angles outside the circle theorem. If a tangent and a secant, two tangents or two secants, so this is covering 3 cases here. This is covering a tangent, there we go, a tangent and a secant. It's also covering two tangents or two secants. The thing that is same about all 3 of these situations, however, is that the vertex of our angle is outside the circle. So if this occurs, if our angle is outside our circle, so if these things intersect outside our circle, then the measure of the angle formed is half of the difference of the measures of the two intercepted arcs. So for all of these, we'll label this angle 1, I guess, or we'll label it angle A. We'll say this is B, C, D, B, C, B, C, D, E. In this first case, the measure of angle A equals 1/2 of, we take our bigger arc minus our smaller arc. So 1/2 of the measure of arc CD minus the measure of arc BC. In the second case, the measure of angle A equals 1/2 of, again, our bigger arc minus our smaller arc. So arc BC, the measure, minus, oh, we should probably add a letter here. So the measure of arc BDC minus the measure of arc BC. And in our third situation, same idea. The measure of angle A is going to be 1/2 of the measure of our bigger arc minus the measure of our smaller arc. So the measure of arc DE minus the measure of arc CB. And those are 2 new theorems.